just as per the board regulations. All right, so we're going to start just by reviewing all of our exponent laws. And we did this way back in the beginning of the course. So the first one is our multiplication rule. So when I have two exponents with the same base and I'm multiplying them, I just add my exponents. So for example, if I have x to the power of 5 and x to the power of 9, that will give me x to the power of 14. So all I'm doing is I'm keeping the base and I am adding my exponents. It's just like when you do x squared times x squared, most people immediately just go to x to the power of 4. Same idea, just different numbers. Now our next one here, we have 3 to the power of 2 times 3 to the power of 1. So we'll just have 3 to the power of 3. Remember, if I don't write an exponent, it's like there's a secret little 1 there. Now, when I have numbers like this, I do want to try to evaluate them. So 3 to the power of 3 is 27. You can do this on your calculator if you don't know them off the top of your head. We're going to be doing so many of these that you'll probably get to a point where you'll see 3 to the power of 3 and just know it's 27. But if you're not there yet, don't stress. You can just plug that into your calculator. Okay, our next rule is our division rule. So if I have two things with the same base, so I have a to the power of m divided by a to the power of n, I keep my base and I subtract my exponents. So for example, if I have x to the power of 6, divide by x to the power of 4, keep the base and subtract my exponents. So 6 minus 4 is 2. For our next one, if I have 2 to the power of 5 over 2 to the power of 3, I keep my base and I subtract my exponents. And because it's a number, I like to evaluate these just in case we have to use them later. So I can change that to a 4. The next rule that you guys have learned on many occasions is our power of a power rule. So that's when I have a power outside of the brackets here and one on the inside. And when I have that situation, I multiply my exponents. So for our first example, if I have x to the power of 7, all to the power of 10, that's the same as x to the power of 70. For my next one, I have 2 to the power of 3, all to the power of 2. So I keep my base, multiply my exponents like this, and that will give me 64. Now there's one other situation that I do want to mention here, just because it's a situation that tends to cause people trouble. Let's say I had something like this. A power of a power situation like this. I have to make sure that this little 2 here is applied to the 6 and to the 3. So make sure that power of a power rule happens on to everything in the brackets. So this will give me 3 squared x to the 12 because I multiply those exponents. So be very careful with that rule. That's just a rule that people have a tendency to forget about, and it just causes common mistakes. Okay, next is the 0 exponent rule. So if our base is not equal to 0, then anything to the power of 0 is just 1. So anytime that happens, it's great because I can just substitute it with a 1. So if I have 1, 0, 7, 2, 6, 3 all to the power of 0, I can just put 1. So whenever that happens, it's really nice because we can just sub everything with 1s. And that is really what's happening when we cancel stuff out in our rational expressions, is it's going to an exponent of 0, so it just turns into a 1. That's where it disappears to, basically. Now our negative exponents, this one is really important that we go over. So anytime you have a final answer, it's very important that you have all positive exponents. It is not proper form if you have negative exponents running through your answers. And if it was on a quiz or a task or something like that, you will lose marks if your final answer does not have all positive exponents. So when I have a negative exponent, it's kind of like it's telling you that it's just on the wrong side of the fraction. So underneath this is a hidden 1, basically. And because that x has a -6 as an exponent, it's telling you it's on the wrong side. So that means in order to write it with a positive exponent, it needs to be in the denominator. So I just move it to the denominator and change the sign on the exponent. Nothing else changes. Let's try this next one. So we have 5m all to the power of -2. So in order to write this with a positive exponent, we need to move it to the other side of the fraction. So we move it to the other side of the fraction, and then we just change the sign on our exponent. And now, similarly to that example I said above, we need to make sure that 2 for that power of a power rule goes on both. So we'll have 5 squared, m squared like this. And that will give us 1/25 m squared. And that would be our simplified answer. Let's try another one. So for example K, we have 1/y to the -13. So that's telling me that that y is on the wrong side of the fraction. So I'm just going to move it to the top of the fraction and change the exponent. Now we don't need that 1 on the bottom. Proper form is just to write y to the +13, but sometimes I like to write it just so our steps are consistent and you can see where everything is coming from. For our next example here, we have 3/4 all to the power of -2. So when I have a fraction raised to a negative exponent, I can flip the fraction inside and then change the sign on the exponent. And the reason why this works is because you could also do it this way. So I could apply that -2 to both my numerator and my denominator. Now what's happening is it's telling me that both of these are on the wrong side. So the 4 is on the wrong side and it has to go to the numerator. The 3 is on the wrong side, so it has to go to the denominator. So it doesn't matter how you do this, you're going to end up with the same answer. So typically, this is the way we like to do it, just because it's a bit of a quicker, more efficient way. But if you forget about that rule, no worries. You can just do it the other way with our fractions too. Okay, any questions before we go on to some more examples? We're going to do a few challenging ones. Yeah, Dimitri, feel free to type your question in the chat. Would the exponents flip too? So when I put my exponent from here onto both of them, it just starts exactly the same. So I had 3/4 all to the power of -2. So that -2 just goes onto both of them. And then all I'm doing when I flip it is I flip it to the other side and I keep the exponent, I just change the sign on it. So they just change to a +2. Same here, it just changes to a +2. But the rule with our fractions is if I have a full fraction raised to an exponent, it can go on both. Yes. So the reason they flip signs is because when I apply the -2 to the whole fraction, I have 3 to the power of -2 and 4 to the power of -2. Then when I switch it, all that happens is the exponent changes signs. Just the exponent, not the base. So not the big numbers, just the little teeny ones. So hopefully that cleared it up. We're going to do a few more examples, so I think the examples will also provide everybody with some more clarity. So again, make sure your answers always have positive exponents. If they do not have, if they have negative exponents, you will lose marks and your answer is not fully simplified. So let's go through a few examples here. So for our first one, we have x to the power of 3, y to the power of 2, all multiplied by x to the power of 2, y to the power of 4. So because I'm multiplying, I'm going to keep my base and add my exponents. So 3 plus 2 is 5. Keep my base, add my exponents. 4 plus 2 is 6. So again, just because I'm multiplying, I add my exponents. For our next example here, we have 2a to the power of 5, b to the power of 3, all over 8a to the power of 2, b to the power of 2. So first thing we do is we look at our coefficients. So we start by dividing or reducing a fraction. So because I have 2 over 8, I can reduce this fraction to 1 over 4, like this. Now I look at my exponents. So I have a to the power of 5 over a to the power of 2. So I keep my base and I subtract my exponents. Next, I have b to the power of 3 over b to the 2. Keep my base, subtract my exponents. So I don't need to write that 1 in the numerator. This would be proper form. I do like to just throw in an intermediate step so you can see how I reduce that fraction. But if you can just jump to the final step, that's absolutely okay. It's also helpful to now see where things go when we were canceling them earlier with our rational expressions. So you can kind of see how we had 5 a's on top, 2 on the bottom, so we're only left with 3. So everything kind of starts to come full circle now when we go through these. All right, let's try another one. So for C, we have 9x cubed multiplied by negative 4x squared times y. So we always start with our coefficients. So we have 9 times negative 4, so that will give us negative 36. And now I go variable by variable. So I'm going to look at my x's. So I'm multiplying, so I keep my base, and I add my exponents. For my y's, there's only one y, so it just stays as one y because there's no other y's to change it. So that is all we can do, and we're done. Okay, let's try another one. We'll go to D. So D has a power of a power rule here. And remember that we need to apply that power of a power rule to everything inside the brackets, including my coefficient. So including that big 5, we need to apply that exponent 3 to all of it. Please be really cautious of that because it's a super common error and it's very easy to do. So that will give us 5 to the power of 3, and I'm going to keep my base and multiply my exponents. And then for my m, I have negative 4 times 3, keep my base, and multiply my exponents. Now we can simplify this a little bit more. So 5 to the power of 3 is 125. N to the power of 9 has a positive exponent, so it stays living in the numerator. But for m, I have an exponent of negative 12. This means it cannot be in the numerator, and it has to be moved to my denominator. So again, when I move it to the denominator, all that happens is the sign on my exponent changes. So everything else is the same. It's just instead of writing negative 12, I write positive 12. And that would be our final answer. That's as simplified as we can get that. Okay, let's try another one. So for E, we have a power of a power rule again. We have x to the power of 2, y to the power of 3, and all of that is raised to the power of negative 2. So we're going to start by just using our power of a power rule like we always have. So 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. Now I address the negative exponents. So because x is to the power of negative 4, it's on the wrong side of the fraction. So it needs to live in the denominator. For my y, because it has an exponent of negative 6, it's on the wrong side of the fraction, and it needs to live in my denominator. Because I have nothing left in the numerator, I can just put a 1. And that is my final answer. So the easiest way I find to approach these is just do our exponent laws the way we always have, and then address the negative exponents at the very end. So it's almost as if we're just adding an extra step on the end instead of trying to do it all as intermediate steps. Okay, let's move on to F. We're over halfway done all these examples. So we have negative 8, x to the power of negative 4, all over 2x to the power of negative 2, all to the power of 2. So the first thing we always do when we have multiple operations going on is we always deal with the power of a power first. So no matter what, you're always going to deal with power of a power first. So let's work with that power of a power first. So we're just going to leave that negative 8 x to the power of negative 4 alone, and it can just hang out for a little bit. And now we'll deal with the power of a power. So on the bottom, 2 to the power of 2 is just 4. And now we are using our power of a power. So negative 2 times negative 2 is negative 4, like this. Now we'll continue simplifying. So we start with our coefficients. So negative 8 divided by 4 is going to give me negative 2. And now we look at our x's. So I have negative 4, subtract negative 4. That is 0. So that would give me just negative 2. Now what we've often done is we've often looked at this and we've said, oh, those just cancel, we get rid of them. And that is basically what's happening. And the reason it's happening is because of this little x to the 0 here. That's where they're going. They're not just totally disappearing into thin air. They just have an x to the power of 0, so they just equal 1. You are more than welcome to jump from here to here, but I just like to show you why it happens, because sometimes that helps people to get a deeper understanding of what we're actually doing. So feel free to jump from there to there. You don't need to write all these intermediate steps if you don't want to. Okay, let's go to G. We only have 3 more left. We're almost done. So for G, we have 6x to the power of negative 5, y to the power of 2, all over 3x to the power of negative 7 times y, all to the power of negative 3. So we always start with our power of a power first. So let's apply that to everything in my brackets. So we will have 6 to the power of negative 3, x. So I'm doing power of a power, so I multiply my exponents. So negative 5 times negative 3 is going to give me positive 15. Y to the power of 2 multiplied by my y to the power of 2, I take my exponents. I do 2 times negative 3, so that'll give me y to the negative 6, all over 3 to the power of negative 3, like this. My x, we have negative 7 multiplied by negative 3, so that would be positive 21. And then my y has a secret 1 here, so 1 to the power of negative 3 is negative 3, like this. Okay, so now we're just going to move things around so that we have positive exponents. So my 3 to the power of negative 3 is on the wrong side. So that has to move up here like this. Same with my 6. My 6 has to have a positive exponent, so it needs to live in the denominator. Now, my x's, I'm just going to simplify those. So I'm dividing, so I subtract exponents. So 15 minus 21 is going to give me x to the power of -6. And then my y's, I have y to the power of -6 over y to the power of -3. So I just subtract my exponents. -6 minus -3 is going to give me y to the power of -3. So now I will deal with those negative exponents. So I will have 27. My x is negative, so it needs to go on the bottom. Same with my y. There we go, over 216, like this. And that is our final answer. We can reduce that fraction down a little bit if you want. Both of these things are divisible by 9, so if you want, we can reduce the fraction a little bit. Oh, we can even do it one more time. I didn't find my greatest common factor, but that's okay. So that's as simple as we can get it. We always want to go as absolutely simple as possible. So our goal is always to have all positive exponents and then reduce our fractions down as much as we possibly can. Okay, let's try another one. So these ones are getting a little bit more complex, but all the rules are the same. There's just a few more of them. So for this one, we have 25 m to the -1 n to the power of 5 all over 75 m to the power of 2 n to the power of 2. And all of that is to the power of -3. So remember, our first step is always our power of a power first. So we'll have 25 to the power of -3. M to the power of 3. So all I'm doing is multiplying those exponents all over 75 to the -3, m to the -6, n to the -6, like this. So similarly to before, I'm just going to start simplifying things. So this time, just to show you something a little bit different, I'm going to do all the division first. So we're just going to leave our coefficients with those negative exponents for right now, just for a moment, to see if maybe you like this strategy better. So we'll start by dividing our m's. So we have m to the power of 3 over m to the -6. So we subtract our exponents. So 3 minus -6 is going to be +9. And now for my n's, I will have -15 minus -6, which will give me n to the -9, like this. Now let's start moving things around to have positive exponents. So my 25 needs to go into the denominator so that it has a positive exponent. And my 75 needs to go into the numerator so that it has a positive exponent. Now my m already has a positive exponent, so it can live where it already is. But my n will need to move down here to have a positive exponent. And you can go through and expand that 75 cubed and that 25 cubed and reduce it. But just for the purposes of time, I'm just going to leave it there for right now, just so that we can move on to the next one and you can get started watching the video that's after this. Okay, let's do our last example, I. So we have 2x to the power of -3y squared, all to the power of 3, all over x to the power of 3, y to the power of -4, all squared. So again, we always start with our power of a power first. So we'll have 2 cubed, x to the -9, y to the 6. So again, all I'm doing with those exponents is I'm just multiplying them because of that power of a power rule. In our denominator, we'll have x to the power of 6, y to the power of -8. So now let's simplify this a little bit. So we'll have 8 For my x's, I'm dividing, so I subtract exponent. So I have -9 minus 6. So that would be x to the -15. And y, 6 minus -8 will give me y to the +14. And now I need to move that x so that has a positive exponent. So it has to live in the denominator. So that is my final answer. Below, you're going to find a bunch of practice problems for you to do. There are a lot here, and there were some textbook questions I posted on Classroom. If you're looking at that and you've got this and you feel really confident, you don't have to do every single question to get the completion mark for the homework. I just want you to do enough that you feel like you are very confident about this. So you can decide how much that is. For the textbook work, I would suggest doing a few from each question instead of just doing like question 1, because they often are just different or more difficult down the end. So just try to space them out, which ones you want to do.